Good morning, everyone. Myself, Ashu Sharma. I welcome you all in series of SQLite. Today, we will start with briefings of some of the important points related to this wonderful library, which is deployed in C language. So, this is you can say it's a self-contained system that SQLite we have. So now start with that next slide. The very first one is very important point is self-contained. It's a standalone system, or in the sense that it has very few dependencies. That's why we say it as self-contained or standalone. It runs on any operating system and even stripped down bare bones such as embedded operating systems. SQLite uses no external libraries or interfaces other than a few standard C library calls. The entire SQLite library is encapsulated in a single source code file that requires no special facilities or tools to build. So very much interdependency having, and some of these dependencies, which is on some of these C library calls, and something like that, MEM comparison, memory CPY, and move, set, length. These are some of these built up of SQLite requires just these routines from the standard C library. So overall, that SQLite is a self-contained system because it has dependencies, but very few. Now the next one is that SQLite is serverless. Why do we say this? SQLite is a serverless. Most SQL database engines are implemented as separate server process. So with SQLite, the process that wants to access the database reads and writes directly from the database files on disk. There is no intermediate server process. So whatever that operation takes place of read and write that of data, it is directly from the database files. That directly from the database file on the disk, there is no intermediate server process involved. So that's why SQLite is also denoted as serverless. It's a very important feature. Now the next feature is about the zero configuration. SQLite is a zero configuration database. It is good question for quiz contest also, and there is no setup procedure when we talk about the zero configuration. There is no server process that needs to be started or stopped or configured or deployed. There is no need for an administrator to create a new database instance or assign access permissions to users. And SQLite uses no configuration file. So you have to, at the time of the installation that we will see in upcoming videos, you have to just download and install it and save your path in environmental variable. You just do these type of things and you just go with SQLite. So it's a very easy process. There is no that you can say that any intermediate server presence or something which is having that start and stops and then the configuration stuff. You have to just go through, no need even though for an administrator to create a new database instance. So you can say as a conclusion that SQLite uses no configuration files as well. This is another important feature. Now, next one is the transactional. The transactional database is one in which all changes and queries appears to be atomic and consistent, isolated, and durable. As we have seen in previous videos, this ACID property is very important, and SQLite implements realizable transactions that are atomic and you can say consistent, isolated, and durable. Even if the transaction is interrupted by a program crash or due to some fault, an operating system crash or power failure to the computer, we have that options to just recover from that state of crashing or failure. So we here just restate and amplify all these things, and all changes within you can say a single transaction in SQLite either occur completely or not at all. So it's really atomic behavior, and even if the act of writing the change out to that disk interruption any reason, because of a program crash or a operating system crash or a power failure, SQLite having that characteristic of transactional behavior. Now the next is a very important feature is file format, which is again a cross-platform behavior. And the SQLite is the complete state of an SQLite database is usually contained in a single file and on the disk called the main database file. And during a transaction, that SQLite stores additional information in a second file called the rollback journal, or if the SQLite is WAL mode, a write ahead log file mode. So it has that two main that files on the disk. One is the main that database file, and during a transaction, that SQLite stores additional information in a second file called the rollback journal. So this is that in the mode of that write ahead log files. So overall, these are the features that we can say SQLite is very easy to use. Yeah, if you cover this self-contained serverless zero configuration transactional and file format stuff, it is really easy to use. Now, when we talk about SQLite, it is faster than the traditional direct file system. So general findings that SQLite is competitive with and usually faster. And you can say then the blobs stores in separate files on the disk, and SQLite is much faster than direct writes to disk on Windows when antivirus protection is turned on. So this is one of that constraint that we want to use that antivirus protection on the system. So because as I explained you that there is no intermediate that server deployment over there is directly read or write that database values on the disk. So it's a quite fast that track we talk about when we using that SQLite as an option. Next is very carefully tested. Later stages we will see that what are the different ways of testing. But these are four different ways of testing. One of the test is TCL test, which is the oldest set of tests for SQLite. They are contained in the same source tree. TCL tests are the primary test used during the development, and these are written in scripting languages. So it is really very good testing techniques, which is one of the oldest technique, TCL test technique. The next one test technique is TH3 test, which is a set of proprietary tests, which is written in C, and it provides 100% branch test coverage to the core SQLite library. And this is designed to run on embedded and specialized platforms that would not easily support TCL or other workstation services. So TH3 tests use the published SQLite interface. The next one is the SQL logic test, or SLT. It is used to run huge number of SQL statements against both SQLite and several other SQL database engines and verify that they all get the same answer. So this is known as SLT test or SQL logic test, SQL logic test. So next one is the DB SQL fuzz engine is a proprietary fudge tester, and it other fuzzers for SQLite mutate either the SQL inputs or the database files. So this is another that test engine. So overall, we have to apply these four tests. First is TCL, second is TH3, third is SQL logic test, and fourth is that engine is DB SQL fudge. Now come to the next point about that SQLite and all about its characteristics is ACID transactions. As I already explained you in transactional behavior about the atomicity, consistency, integrity, isolation, and durability. So this is really very important concept that that transaction should follow these ACID characteristics: atomicity, consistency, isolation, as well as durability. So to make a database consistent, this is very important, and it always follows that serializability behavior as well. The next provides the bugs list. So it is just having the testing scenario and all sorts of things. So it provides bugs if there is any error or such that interested behavior, or you can say something which is not desirable is happening during that whole process of that successful transaction and that database consistency. So this is that provides that bugs list if anything which is not acceptable is going to happen, so that easy to recover and remove that concept and try to uh, just overcome such problems, so that it would not be the issue in the future once we deal with certain applications and certain behaviors. So here we will try to understand SQLites, and most of these parts are using that Python concept with the Python, and this is very, very useful. You can say a library or SQLite which is deployed in C. So these are some of briefings about how exactly the significance behind the SQLite. If I just conclude these points, so we can say it's SQLite is self-contained, it's a serverless, zero configuration, transactional, having file formats. And some other points are it's a faster than the direct file system and very carefully tested. So we have put in test to uh, find out the bugs and make that database values and database consistent. It follows the ACID transactions and provides bugs. So overall, these 8 points are very important. It is important for interview perspective as well. People might ask you, just give some brief about the SQLite and its behavior. So you may go through this slide and these videos, and you can just get a glimpse of how it exactly uh, work in that direction. So thank you very much for being with me in this session. If you like these videos, please subscribe my channel and press the bell icon so you may get notification when I upload new video. Thank you very much. Have a nice day.